Okay, so we're going to talk about the effects of the scientific revolution, which in affecting and altering our lives today, it cannot be overstated. This is the beginning of modern science, and modern science sets the stage for engineering, inventions, technology that we use. Virtually every bit of modern technology eventually goes back and has its roots in science. The scientists aren't the ones who come up with the actual invention, but they do come up with the theories and how the world works. So eventually the engineers can put that into practice. And this is when the modern scientific world started. Okay, so let's go through a bevy of a lot of different effects. Well, the first thing is I want to mention that although there were many fields in the European scientific revolution, it was not the beginning, and it might have or might not have fully revolutionized the fields. Like, for example, these are world areas of science. Astronomy had the heavens and the planets and the stars had been examined by every single civilization throughout time. As soon as people could record things down and look up, it was all about charting the sky and charting what people saw up there, and it was incredibly accurate. Like the Egyptians' versions of the sky, the Maya versions of the sky, the Muslim Golden Age versions of the sky and what's going on. So the rest of the world has always been doing astronomy, and I get it, Galileo and his sun-centered model. Well, other cultures had postulated that the sun was at the center also. And look, if Galileo didn't use the telescope to see a lot of things with the moon and other planets' moons, someone else in some other culture would have pretty quickly got on that telescope, invented the telescope, and done it too. So yeah, the scientific revolution in Europe did it, but all other cultures were doing astronomy. There were advances in medicine, and again, many other cultures were doing fact-based medicine, okay? So it's like the Western Europeans, they just got on board with what the rest of the world was doing, quite frankly. Same thing with biology. Some would argue that Leonardo da Vinci went farther than anyone else in understanding the workings of the human body, but other cultures would do that too. And if they didn't do it, if he was the first and the most complete, they would have within a couple 100 years or so. And the scientific method, like, we'll talk about how the European scientific revolution becomes the foundation of the world modern science, but the scientific method was not revolutionary in the world. Other cultures were basically doing it, and if they were using observation, they were using proof. Okay, so the European scientific method spread over the world, but it is not something revolutionary that came about during the scientific revolution. It's the one that stuck and the one that makes it with us today. So these are all fields that the world has been doing for thousands of years. And there were advancements in Western science during the scientific revolution, and it did spread around the world. It wasn't anything that is the lightning strike of, oh my gosh, that is 100% a quantum, not yet, quantum leap in thought of science. Now, there were a couple of these quantum leaps, not yet quantum, but leaps ahead that is just literally never thought of, never worked on before. And Isaac Newton developed Newtonian physics, literally a way of looking at the world that worked and still works today on a macro big level. I mean, it was just a theory of the universe that was so practical and so useful, including gravity and motion, that you could use Newtonian physics and be right about the universe in anything but extremely specific and scientific fields of study. It's just for the 99.9% of all people's knowledge. Newtonian physics is a fundamentally perfect way of looking at the world to predict almost anything you would encounter in your daily life. Here's a quick aside on the models of the universe that started with Isaac Newton, just on the side because I'm very interested in it. And this is simplified and I might miss a couple things, but these are the majors. It started in the scientific revolution where Newtonian physics explained how the whole universe worked, basically. No atoms or anything, they didn't know about that yet. It's just how things move with gravity. And Newtonian physics could be explained to anybody given enough time and enough examples. It's very, very straightforward and elegant in its simplicity, and it works so well, usually. But then there's some really weird things that Newton can't explain and his model can't explain, and that's where Einstein comes in and has a totally different view of space and time. Space is not constant, time is not constant. It just fits and explains things that Newton's physics can't. This is tougher to understand, and you need a good few hours to really wrap your head about how things might work under Einstein's theory. It's not, it's definitely in depth, and it comes to be like even time doesn't even flow in the same rate to everybody. It gets complicated. But it doesn't explain everything, especially when you get into the small world of atoms. And so then people started thinking of what's called quantum theory. And there was the first quantum theory explaining of how things might be in the sub-atom particles when things get really, really, really small. And it explains a lot. And then we get into modern quantum theory, which is it is entirely almost impossible for an average person to understand. And a lot of the theory is really just math that explains things, but is almost impossible to, as a human that exists in the world and not existing in math, to understand and find analogies to. But the math equations kind of work to explain some stuff. But you notice something's really interesting here as the theories get more and more. And this is one of those, the scientific method, in the fact that something may explain the universe really, really well, but if it doesn't explain it fully, and if you find things you just can't, things that don't fit, that means there might be another way of looking at it. We don't know if Einstein's way is the perfect way of looking at it. Well, it isn't the quote-unquote perfect, because then in comes quantum, and then modern quantum. And modern quantum might not be a way of looking at the universe that explains everything. So there's another theory that we're thinking of getting to. We just don't know what it is yet. And these theories that work really, really, really well started with Isaac Newton. Now, there's a little bit of a debate, too, who actually came up with calculus, whether it was Isaac Newton or someone else along at the same time. And like any historical debate, the winner is the one that gets the recognition. So Newton is considered the creator of the math of calculus. Whether it was entirely true or not, he gets the press. And so then the average person says, Isaac Newton, calculus. Calculus is a way of looking at numbers and using math equations to solve problems. And to my knowledge, no other place in the history or the world was using calculus. And if someone can find me someone that isn't Isaac Newton inventing calculus in the world, it never caught on. So we would say with certainty that Newtonian calculus, and plus maybe the other person doing it at the same time during the scientific revolution, that calculus is what caught on. So many equations and problems and ways of looking at the world were simplified by using an entirely new type of math, hugely important, that can be taken into inventions in engineering, and it just saves so much time. It solves problems that algebra cannot solve. And what does that mean to us? Well, eventually it means we can make things that make our lives better, inventions in engineering, because of the use of calculus. And it was during the scientific revolution, for the first time in history, well, maybe someone had thought of it, but for the first time we see it and can test it, the microscopic world. The world that is smaller than the eye or a magnifying glass can see. And that's because of the use of the microscope. And from the microscopic world, we get germ theory, we get small little amoebas, everything like that. And eventually we get the idea of, oh wow, there's something we can't see. Eventually people are going to use the concept of the microscopic world and go all the way into atomic theory of atoms. This cohort and cadre of scientists were an inspiration for the next major curiosity revolution in Western Europe that was called the Enlightenment. the next generation of thinkers. But this next generation of thinkers thought of the theory of human rights and how humans should form a government. And you can just think the Enlightenment in Western Europe was when the Western Europeans started writing down the right to life, the right to property. And just human rights had to start in the Enlightenment, right after the scientific revolution. And the idea, I get it, democracy and voting had been around since the Greeks, but as a theory that it should be where society goes, the theory of democracy is coming out in the Enlightenment. And the scientific revolution, trying to find the truth or new theories of the universe, led for these philosophers, and many of the philosophers were actually scientists. They took the same idea to say, can we form universal truths and laws of nature that govern human rights? Yeah, and so would the Enlightenment happen without the scientific revolution? I think 100% true. Many people say the scientific revolution led to the Enlightenment. Look, it helped at least. And finally, the scientific revolution that happens with Galileo and Newton and, I say, Da Vinci in Western Europe, it becomes the foundation for modern science. There's literally almost no science existing in the world today that doesn't have its start in the scientific revolution. And let me tell you a very interesting theory of why that would happen. So let's take a look at this map and let's remember what was happening during the 15, 16, 17, 1800s and the early part of the 1900s. The Europeans were colonizing. So here we have the Europeans. They're going through the Renaissance, the Enlightenment, the scientific revolution. So they are figuring out their own scientific method. And you know what? Guess what? Like, China had its own scientific method. But Europe's making its own scientific advancements. And the rest of the world was populated. So think about it. North America gets entirely colonized by the Europeans. So then the culture of the humans that were in North America gets replaced by European culture. And some of the indigenous culture remains, but not necessarily the science. The same with Central America and South America. So yes, there's still aspects of culture, but the science was replaced by European science. Then in the 1800s, literally 95% of all of Africa and the civilizations of Africa were colonized. The cultures weren't wiped out, but the education and the science was roughly replaced by European education and science. India was taken over by the British, replaced with English science. Australia was colonized by the British. Southeast Asia was also colonized, and there wasn't a lot of civilizations. There were tribes and there were many people, but huge civilizations with established science wasn't there in the beginning. Regardless, was colonized by the Europeans. China had its own history of science and its civilization, and China was economically imperialized, and then through revolutions, the Chinese communists came to power, which adopted the industrial ways of Europe, the USSR with factories, and in with it came the science of Europe. And so the communist Chinese adopted a science based on the European communist science. Japan was never really taken over, but when Japan opened up to the world, they specifically, whatever science they had under the Tokugawa, the Meiji science looked to the rest of the world, specifically the United States and the Europeans, and they changed their education system and their science system to model the European system. And then the Middle East was taken over and colonized by the Europeans. And so the education system gets reintroduced. So you have the idea of Muslim Golden Age science, but it gets taken over and mixed with, more so here than other places, but mixed with and replaced by European science. So where we are, in this whole area, is basically Russia. So basically what we have going into 1965, the majority civilizations of the world have been influenced, if not taken over educationally, by the European scientific model, which started in the scientific revolution. And now that the rest of the world is mostly free and autonomous and they have their own governments, they are still using the education standards that were introduced during the time of colonialization. And so the places that are using the scientific method, the places that are using other things of science come right from the history. Even if they had their own science in ancient history, the science being used today is coming from the scientific revolution. And so that's why that's why I would say that the modern science is coming from this scientific revolution, for better or for worse. The scientific revolution is the foundation of modern science. Those are the big effects of this time period, the scientific revolution.